Hello everyone and welcome to my channel. My name is Dr. Korachi, and in this video we will discuss advanced threat detection techniques with focus on behavior-based detection. Now, the behavior-based detection is a very essential concept in the cybersecurity because simply it shifts the focus from those traditional signature-based methods we discussed before to identifying unusual or suspicious behaviors within systems, users, or even networks. Now, this approach is very important for early detection of new and sophisticated cyber threats, which is, as you are aware, is constantly evolving and often evading those normal or conventional detection methods. Now, we going to talk about what is the behavior-based detection and operation fundamentals, techniques, advantages versus disadvantages, corporate scenarios, and finally, what type of solution is available out there. Now, first of all, it is considered as a proactive approach that monitors user behavior or, like I said, system or networks to identify and protect against malicious activity. It's considered one of the most efficient ways to protect against advanced threats like, ransomware and even zero-day, malware. It involves observing a system activity to differentiate between what is considered to be normal and what is abnormal activity. It uses machine learning, by the way, techniques to identify unusual patterns that deviate from the regular patterns or usage that indicates malicious activities that could occur from cyber attacks. Now, by the way, the reason why they've been integrating machine learning for a long time because it will enhance the behavior-based detection by automatically learning and adapting to evolving pattern of normal and malicious behavior, which means it's going to improve the accuracy and efficiency in identifying those threats. Now, it assumes that while the characteristics of malware can change, the behavior patterns they exhibit often remain consistent. Also, it helps in detecting new and unknown threats by observing deviations from established patterns. It is more qualitative and focuses on understanding and tracking specific type of behaviors or even sequence of action that may indicate a threat. The behavior-based detection also programmed to analyze, evaluate every single line of code and analyze all the potential actions that may be performed by that code, like accessing, critical or important files or processes. If a user, for example, behaves in a way that is suspicious or abnormal, the system can detect it and take action. Now, to understand the core operation, you need to look at what important things happens behind the scene, like the baseline establishment, continuous monitoring, alerting and response, and finally the feedback or update. Now, the baseline establishment, what is the baseline? The baseline is basically, think about it, that's the normal behavior that must be established before the behavior can be classified as abnormal. Now, this baseline is created by monitoring system, network, or user activities over time so it can build up the baseline. Now, as a process, how it works, it starts collecting data on a standard operation, like, the user activities on a daily basis, the type of network traffic flowing inside your network, the system processes that usually run into your system, and also even the application installed on the system, how it's behaved. So the outcome of the whole process here is that a detailed profile representing typical behavior is generated. Now, this will serve as a reference point against which future activities will be compared. So that's the first step. Now, the second step here we have the continuous monitoring here. Now, in this process here, the definition, the system continuously monitors and records all activities once the baseline is established. The process is based on real-time data collection from different sources, the one I just mentioned, like network traffic, system processes, user action. The outcome here right now we have constant stream of data ready for analysis against the baseline. In the third step, I meant alerting and response. What does it mean? I mean, once an anomaly or suspicious behavior is detected, the system generates alerts and can initiate predefined response action. The process basically depends on the severity and confidence of the detection. The system in this case will take certain action, from sending an alert to the administrator to automatically isolating affected system or even blocking this. And all depends on the feature of the system you have. The outcome, now this is very important because right now we have quick response to potential threats, which means we will minimize the damage and we'll be able to contain the threats very quickly. Now, the last part here, we have the feedback or the updating. Now, constantly, and continuously updating the behavior baseline and the heuristics based on the new data and confirmed threat, this is very important. The process is, as threats are confirmed or false positives are identified, the system learns and adjusts its baseline and rules. So what's the outcome? Well, we have better accuracy and less false positives over time. Now let's look at the techniques here. Now the first one is we have the stateful protocol analysis. This technique basically monitors, analyzes the state of the network protocols over a session. It checks whether the sequence of activities within a protocol is legitimate based on predefined protocol standards and behaviors. By tracking the state of the session, it can identify deviations, of malicious activity. The second one here, we have the data flow analysis. This approach monitors data flow through the system or network, looking for patterns or behaviors of malware or attacks. It can identify suspicious data movement, such as large amount of data being transferred to some other country that could indicate a data breach, attempt. The third one here, we have code behavioral analysis. This is unlike signature-based methods that look for known malware signatures, as I discussed in the previous video. Now, this technique analyzes the behavior of executable code. It monitors the actions performed by a program when it is executed, such as attempts to access certain system files or make network connection to identify, malicious intent. The fourth one here, we have the user behavior analytics, UBA. Now, this thing focuses on detecting deviations in user behavior. Now, this is, the first step, like I mentioned before, we need to establish a baseline of normal user activity. See, this tool can identify any actions that deviate big time from its baseline, such as unusual login times or location, or even accessing files outside the user's normal work hours. Application behavior monitoring, that's another important thing because we have a lot of applications installed on our computer system. Now the behavior-based detection monitors the behavior of those applications and services on the system. Anything that is unexpected application launches or unusual system level operation or even unauthorized changes to system settings will be flagged. Context-aware behavioral monitoring. Now, this method considers basically, the context of certain, activities, like the time of the day or the network overall state. Now, by understanding what is normal in a given context, it can more accurately identify behaviors that are really suspicious. So here you could say that these techniques I just mentioned in this slide and the previous one are central to behavior-based detection. Rely on understanding and monitoring the expected patterns of system, network, and application, and even user behaviors to identify deviations that may indicate a security threat. Now, there's no perfect system out there. There is always advantages and disadvantages. Now, let's take a look at the advantages here. Now, first of all, this type of system can adapt quickly to new and previously unknown attacks. It is very efficient, more than using or implementing manual security measures. It has a low false positive rate, compared to legacy system. It is much more difficult for attackers because it requires users to actively engage in malicious behavior, making it difficult for attackers to remain undetected or change their identity. Now, the disadvantages here. Now, first of all, it is resource intensity. Well, because monitoring and analyzing behavior can be resource intensive, requiring significant processing power and memory, and this might impact system performance, especially in large or complex environments. Now, in high complexity here, yes, implementing and managing a behavior-based detection system can be complex because it requires, setting up and maintaining detailed behavioral baseline and always adjusting these to reflect changes in the network environment. Now, potential for false positive, well, we know that it reduces false positives. However, this system can sometimes miss threats if the malicious behavior closely mimics legitimate activities leading to false negatives. Now, dependence on the baseline quality, that's extremely important. The effectiveness of this type of system depends on the quality of the baseline rules established there. Poorly defined or outdated baselines can lead to both false positives and false negatives. Challenges in defining normal, defining what constitutes normal behavior in a constantly changing IT environment, it is definitely for sure challenging, and especially in diverse and dynamic networks. Also, it is time consuming. It takes time to analyze the behavior of the object. However, while behavior-based detection offers advanced and adaptable protection against a wide range of threats, including unknown or emerging threats, its effectiveness depends on the resources available, the complexity of the environment, and the quality of the baseline behavior definitions. Balancing these factors is extremely important for maximizing the benefits of this approach and minimizing its limitation. Now, we need to talk about possible corporate scenarios based on the different categories and how behavior-based detection works. This will help you to understand the concept very well. Now, the first one, for example, like malware and ransomware detection. Scenario: employee downloads a file that starts encrypting files on the network. So what does the system do? The system will detect the rapid file encryption as abnormal behavior and isolate the affected system. The result? This quick response prevents the spread of ransomware, saving the company from significant data loss and ransom demands. The other one here, anonymous access control. Now, in this particular scenario, the user credentials are used from geographically distant location to access, confidential resources. So what the system will do, the system recognizes this as irregular based on the user login history and issues alert. The result, the security team responds quickly by blocking the access and resetting the user credential, preventing potential data theft. Another scenario here, which is very common when inside the threat detection, the scenario, an employee is accessing sensitive files and transferring large amounts of data to external drives at unusual hours. The system will flag this activity as a deviation from employees' typical behavior and alerts the security team. The result, the system team investigates and discovers an insider threat. They prevent data leakage, reinforce data access policy, and take legal action against an employees in this particular scenario. Now, the other serious threat is the advanced persistent threat, APT detection. Well, persistent connection, for example, in this scenario, to a foreign IP address, and unusually data packets are sent from a critical data server. Now, the system identifies these patterns as potential APT indicators and alerts the cybersecurity team. The result, the team will jump in and isolate the server, perform forensics analysis, identifies an APT, and prevent a major data breach. Another scenario could be cloud security monitoring. Like, for example, a sudden spike in the data resource usage indicates potential unauthorized service deployment. So the system in this case will flag this as abnormal and alert the IT team. The result, the IT investigates and finds a configuration error preventing data leakage and unauthorized resource usage. The other scenario here, we have abnormal application activity. For example, like an application installed in a system begins to perform unexpected action, like accessing system files, make some configuration changes. The system detects this action as suspicious and isolates the application. The result, this prevents the application from causing further damage, and a deeper investigation reveals a malware infection. Another common scenario here, we have the suspicious email activities, like an email account in the corporate starts sending phishing emails to large number of people inside the organization. The system will flag this as a sudden change in email pattern and alerts IT. The result, this particular compromised account is blocked or secured, and the company conducts an employee awareness session on phishing, enhancing overall email security. And the last one here, irregular financial transaction scenario. High value transactions are made at unusual times, inconsistent with normal operation. So what the system will do in this case? Well, this particular transaction will be flagged as abnormal and will be reviewed by someone. The outcome, the review uncovers a financial fraud attempts, leading to improved transaction monitoring and the law enforcement involvement in fraud handling in certain cases. Now, there are many different type of solutions out there, that's available. For example, the first one is the CrowdStrike. It performs behavior analysis by applying advanced analytics and expert-generated intelligence to process trillions of data points regularly collected by the cloud native by the same company. It's called Falcon platform. We have Darktrace, uses machine learning to detect, respond to, and mitigate cyber threats in real time. Splunk provides security information and event management SIM solution that leverages behavior-based analysis techniques. And also and many another companies. There's another thing to mention is that the behavior-based detection plays a major role in digital forensics. Why? Well, because forensics experts analyze the behavior of systems, networks, and users to uncover the methods and extent of the cyber attacks. This can involve examining log files, system changes, network traffic, and other indicators to construct the sequence of events in a cybercrime incident, which is very helpful to write a very good, decent forensics report. Furthermore, behavior-based detection methods are also vital for intelligence communities because they gather information, of course, by monitoring, analyzing patterns in cyber activities, law enforcement can anticipate and mitigate potential threats. As I stated before, it is a proactive approach. However, I encourage you to read the features of these type of applications so you can gain insight of how these applications can be used in enterprise level. In conclusion, by incorporating behavior-based detection into cybersecurity strategies, individuals and organizations can enhance their defense against cyber threats, reduce false positives, and maintain compliance with industry regulation. Furthermore, understanding this concept is important not just for cybersecurity professionals, but also for educating non-technical users or even for students who wants to enter into the cybersecurity field. Now, the next video is about anomaly detection. You will understand anomaly detection, how it works, and how it is different from behavior-based detection. Finally, thank you so much for watching this video. If you like it, please subscribe to my channel and hit the like button so you will be notified when I release new videos. Again, thank you so much for watching.